Hi, I'm Luc van der Wielen, Director of the Bernal Institute at the University of Limerick. Today I'm to talk about how our research in structured materials relates to the development of disruptive solutions for grand challenges in energy and the environment. Improved energy efficiency, renewable energy, and aggressive carbon emission reduction are pillars under several of the United Nations Sustainable Development Goals. Novel and advanced structured materials play a key role in achieving those objectives. The University of Limerick has invested since 2010 significantly in its Bernal Institute in all elements of structured materials research. Our vision is to become the leading international research institute for the scientific design and manufacture of structured materials to meet those global challenges, particularly in areas of health, energy and the environment. We do so by developing disruptive solutions related to those vast challenges in sustainable energy and resilient climate through our capabilities in discovery and analysis, modeling and design, and advanced manufacturing. Bernal research focuses on the synthesis, the making, the characterization, measuring, and the design, inventing of nano, meso and macro structured materials across 4 research clusters to provide potential global solutions for global grand challenges. The Bernal research clusters are molecular and nanomaterials, biomaterials, composite materials, process engineering. Our research in structured materials ranges from the molecular and nanoscale, since performance of structured materials is determined by the molecules and the local nanostructures. Bernal Institute is home to one of the world's highest resolution electron microscopes that allow imaging even at smaller scales than atomistic. The micrometer scale that characterizes living cells and thereby biomaterials, to the very large scale of composite materials for wind turbines, aircraft and ships, and in the future also lightweight construction works, but also actively developing, testing and demonstrating manufacturing processes in its process cluster. Some examples of our research in each of these clusters are: breakthrough in emission-free transport in urban environment are unthinkable without novel molecular and especially nanomaterials for high-capacity, fast-charging batteries. Energy management is key at society level, but energy management also plays a role in a much smaller scale. For instance, electrically driven implants, such as pacemakers and brain implants, require minute amounts of energy, but once implanted, should ideally last a lifetime. Implantable energy harvesting systems contribute to the quality of life by continuously providing energy to those biomedical devices. We have developed biopiezoelectric materials on the basis of natural building blocks such as amino acids and proteins. These biomaterials translate bodily motion sustainably in electrical energy, minimizing the need for invasive and costly surgery. And the costs are just a fraction of today's commercial piezoelectric materials, and they are fully renewable. Let's go back to large-scale societal energy demand. Clean wind energy technology and sustainable aviation all depend on breakthroughs in composite materials, which are ultra-lightweight structures of strong carbon fiber glued together by weather-resilient polymers. Cost reduction is essentially achieved by scale-up of those wind turbines and airplanes. And the key challenge is to manufacture those large structures up to 100 meters or even more in just one efficient step. Bernal also explores the circularity and carbon footprint of the base materials. For instance, high-performance composite materials require carbon fiber. Today, that's manufactured from fossil resources such as crude oil. We have developed a carbon fiber manufactured fully sustainably from bio-based resources such as lignin, which is a residue from the paper and forestry industry. Similar developments are ongoing in our battery research that explores abundant or recyclable resources instead of using rare metals and non-renewable materials. There are many options to design novel and advanced structured materials for solving grand challenges in energy and environment. To understand how these materials perform, we have developed sophisticated computer models. These allow design from the desk while reducing costly experimental work. And if we have to do experimental work, the testing is executed in high-throughput instrumentation. Computers also play a big role in the smart manufacturing of advanced materials, especially for complex structures at a large scale. We just gave you a few examples of our research. With all these possibilities, modern structured materials research is not carried out by a single individual. The Bernal Institute brings together over 400 scientists under one single roof from all relevant fields, such as chemistry, physics, biology, mathematics, as well as mechanical engineering, aeronautical engineering, and process engineering, connecting to academic and industry partners all across the globe. Bernal Institute at the University of Limerick is committed to working with its academic and industrial partners across the globe to jointly develop solutions for United Nations Sustainable Development Goals in energy and climate.